Hey there everybody, Mr. Dickin here, and in this video we're going to continue our discussion into conditional probability. Today we're going to be organizing our data using something called tree diagrams. Now just as a reminder, conditional probability is the probability of A given B. And the way we calculate that is whatever comes after this given that, whatever comes after is the condition that we are working under. All right, so we're kind of narrowing our focus instead of the overall possibility. We're only focusing on the possibilities existing within outcome B. And then the numerator would be kind of both A and B. So that's going to be what we focus on here when we go through our calculations. Now, let's talk about tree diagrams. What are they? How do they work? So a tree diagram is a way to kind of organize your thoughts using a linear path for the occurrence of events. So here we have an example for a coin toss. We'll start from a single point and then we draw our different possible outcomes from there. Well, for flipping a coin, assuming it's a perfectly weighted coin and it's impossible to land on its edge and there's no friction, yada, yada, yada. Assuming it's a perfect coin, there's a 50-50 shot that it'll either land heads up or tails up. Whenever we're drawing out our branches, the sum as you add down should add up to 1 for a 100% chance. So 100% of the time, one of these things will happen. Now you can also extend extra layers beyond the branches, and that's going to represent a second event. So here we have the first coin flip, 50-50 shot. The second coin flip, also 50-50 shot. On each pair or set of branches, these would add up to be 1. Now, if I wanted to calculate the probability of flipping heads then another heads, or heads then a tails, or tails then a heads, tails then a tails, what I would do is I'd multiply as I go along the branches. So once we have our tree diagram created, we multiply along the branches to get our probability. Now, as you add straight down to the very, very end, just like the other branch sets would do, those products should add up to be 1, meaning 100% of the time, one of these outcome combinations would happen. Okay, let's see an example. A bag contains 4 red marbles and 6 yellow marbles, meaning there are 10 total marbles. Draw a tree diagram that lists the possible outcomes of randomly selecting 2 marbles with replacement. All right, so I'm going to start off by drawing my first set of branches. The option here is I either select a red marble or I select a yellow marble. Those are the 2 possible outcomes. The probability of selecting a red marble would be 4 out of 10. And you could reduce that to 2/5 if you want, and the yellows was 6 out of 10. If I added straight down here, 4 plus 6 would give me 10 out of 10, 100%. So that's the first occurrence. Now, we're going to pretend like we put that marble back, whatever we drew out, and we go in for a second marble drawing. So the second set of branches is going to represent the second drawing. Now, if done correctly, these branches should have matching data on there. Okay, so they're both going to have a red or a yellow, and they're both going to have the probability of selecting a red. Since we didn't remove a marble, it's again going to be 4 out of 10, yellows 3 out of 10, or sorry, 6 out of 10, which would be 3/5. All right, so now that we have our tree diagram set, what I can do is kind of compile my data and say the likelihood that I draw a red and then another red marble would be, let's see, 4 times 4 is 16, 10 times 10 is 100. So the probability of that happening is 16 over 100, and that reduces down to 4/25. The probability of drawing a red first and then a yellow, so red, then a yellow, as I multiply across, it'd be 4 over 10 times 6 over 10. So I'm following this path here. 4 times 6 is 24, 10 times 10 is 100. So I'd have 24 over 100, which would reduce to 6/25. Now we get into what if I draw a yellow first and then a red. So if I draw a yellow first and then a red, that would be 6/10 times 4/10. Well, that's going to be the exact same as right above it. So 24 100ths, 6/25. And then lastly, what's the probability of drawing two yellows in a row? So a yellow and then another yellow, 6 over 10, 6 over 10. That would be 36 over 100. And of course, that will reduce as well. So now I want to find what is the probability of selecting two marbles that are the same, two marbles that are different colors. Well, there's two different outcomes for that. I could either select a red, then a yellow, and there's a 6 out of 25 chance of that happening. Or I could go yellow and then red, and there's a 6 out of 25 shot for that happening as well. So what we're trying to figure out is what is the probability of getting two different colors. So we're either going red then yellow, or we're going yellow then red. The word or indicates that we're going to be adding. And the probabilities of each, we had 6/25 and 6/25. We add those together to get 12 out of 25, or 48% chance. All right. Let's see a similar one here. A bag contains 4 red marbles and 6 yellow marbles, so 10 total now. We're at 10 total. We want to draw a tree diagram without replacement. So this one's going to look very similar, only now we are not replacing, so that second draw is only going to have 9 marbles left. So the first draw, we're either going to go red or yellow. And then the second draw, the second set of branches, will also be red or yellow. Now, since we're doing this without replacement, these branch pairs might not match anymore. So the first outcome for the red marbles, there's 4 out of the 10 possible, or 2/5 if you want to reduce. Yellows were 6 out of 10. Now for the second draw, there are only 9 marbles left. The first branch, we're assuming, has already taken place. So if I've already selected a red marble, there are only 3 remaining red marbles out of the 9 total. There are only 3 remaining marbles out of the 9 total. We still have all 6 yellow marbles, but there are still 9 total yellows. This pair of branches should add up to 1. 3 plus 6 is 9. Over 9, that works. Now down here, if I already pulled out a yellow marble, there's still all 4 red marbles available, but there's only 9 total. But if I already pulled out a yellow, the probability of getting a second yellow, I started with 6, there's only 5 yellows remaining out of the 9 total marbles available. So now when we calculate our probabilities, we've got red, then another red. We've got red, then a yellow. We've got yellow, then a red. Or we've got 2 yellows back to back. To get these probabilities, we multiply along the branches. So 2 reds in a row, I'd have 4 over 10, 3 over 9. So that would be 12 over 90. 12 over 90. And that's going to reduce to 2/15. If I go red, then yellow, that'd be 4 times 6, 24 over 90, so 24 90ths. And that's going to reduce to 4 over 15. It's reducing down by a factor of 6. Yellow, then a red. We'd have 6 and then 4. So same as before, we're going to have 24 90ths, 4 15ths. And then yellow, we'd have 6 tenths and 5 ninths. 6 times 5 is 30 over 90. Well, that would be 1/3. Now, if we did this correctly, all of these should be able to add up to be 100%, or 15 out of 15. So 2 plus 4 is 6, 6 plus 4 is 10, 10 15ths plus 1/3. Well, 1/3 is 5 15ths, so 10 plus 5, yeah, that works. All right, so now we want to get the probability of selecting marbles that are different colors. So I'm just going to kind of steal this over. Probability of selecting red then yellow or yellow then red. I'm going to use the same marble paths as before. So on red then yellow or yellow then red, well, that's going to be 4 15ths and another 4 15ths. That's going to be 8 15ths. So slightly over 50%. Here we've got a completed tree diagram that we'll kind of discuss. And then I'll show you the answers that follow there. So here we have a school system compiled the following information. 85% of students graduated from high school. So that's this first branch here. You either graduated or you didn't graduate. Now they didn't tell me about this 15%, but I can kind of infer that if 85% did, then 15% did not. And to do that, I just did 100 minus 85%. Of the students who graduated high school, 90% are happy with their present jobs. So from the graduation, folks, 90% of them are happy. Well, if 90% are happy, that means 10% are not happy. So of the graduated folks, 90% are happy, 10% are not. Of the students who did not graduate, so this branch down here, 60% are happy, which means 40% are not happy with their jobs. Once we have our tree diagram set up, we multiply along the branches. So 0.85 times 0.9, 0.85 times 0.10, 0.15 times 0.6, and 0.15 times 0.4. Now we can answer the questions that follow. What is the probability that a person from the junior class is graduated and is happy? So we want the probability someone's graduated and happy. So they graduated and they're happy with their job. That's the 76.5% here. Probability that a person did not graduate and is happy. So we'd go down to the did not graduate and are not happy. Nope, not graduate and are happy, which is that 9% there. So having that tree diagram certainly helps us. Let's see another one here. A football team has a 70% chance of winning when it doesn't snow, but only a 40% chance of winning when it snows. So it seems like whether or not there's snow on the ground kind of influences our winning or not. Suppose there's a 50% chance of snow. So, first branch, it either snows or there's no snow. And they tell us that that is a 50-50 shot. So it either snows or it doesn't. Now, if it snows, let's see, we have a 40% chance of winning. So if it snows, we've got a 40% chance of winning. That means there's a 60% chance that we're going to lose. Now, if it doesn't snow, it says we have a 70% chance of winning, which means there's a 30% chance of losing. From there, we would multiply along the branches to get our percentages. So I've got 0.5 times 0.4. That would be 0.20. 0.5 times 0.6 is 0.30. Down here we'd have 0.35 and 0.15. And this question is asking, what is the probability that the team will win? Well, the team can win in two different scenarios. Either it's snowing and they win, or it's not snowing and they win. So I would add these two probabilities. Because if I want the team to win, I'm finding the probability that there's snow and they win, or probability that there's no snow and they win. So we do 0.2 plus 0.35. This team has a 55% chance of winning. All right, last and final one. Here we have a tree diagram that's already been filled out mostly for us. This tree diagram is relating snowfall and school closings. So we have H, L, O, and C is heavy snowfall, light snowfall. So the H and the C's talk about heavy versus light snowfall. And then the O and C, that represents if school is open or school is closed. Find each probability. Okay. Well, first, I'm going to go ahead and multiply along the branches. So we're going to multiply 0.4 times 0.8, 0.32. 0.4 times 0.2 is 0.08. 0.6 times 0.3 is 0.18. 0.6 times 0.7 is 0.42. If you wanted to write this as 32%, 8%, 18%, 42%, that's totally fine. Okay. First one, probability that school is closed. Well, that could happen in two different ways. We could either have heavy snowfall and school is closed, or there's light snowfall and school is closed. So there's two different outcomes in which that happens. There's a 32% chance that it's closed with heavy snowfall, but there's an 18% chance that there's light snowfall, so we'd add those together. There's a 50% shot of school closing if there's snow on the ground. What's the probability that there's heavy snowfall and the school is open? So heavy snowfall and the school is open. Well, we're looking for heavy and open. That's just this 8% right here. So heavy snowfall and the school is open, 8%. Next up, what is the probability of having light snowfall given that the school is open? So I need to figure out, first off, what is the probability of light snowfall and school is open divided by just what's the probability that school is open? Well, the probability of having light snowfall and school being open, light snowfall and school is open, that's 42%. So 0.42 over probability that school is open. Well, that can happen in one of two scenarios. School could be open if there's heavy snowfall. School could be open if there's light snowfall. 0.08 and 0.42. So I'd add those together. So this now becomes 0.42 divided by 0.50, and that's going to give me 0.84 or 84%. So probability that there's light snowfall given that the school is open, 84%. Number 4, what's the probability that there's heavy snowfall given that the school is closed? Well, I want to know what is the probability that there's heavy snowfall and the school is closed over just what was the probability that school is closed. Remember, when we're doing these conditionals, whatever comes after that conditional clause should be our denominator. Well, the probability of heavy snowfall and school being closed would be heavy and closed, that's 0.32. And we already found out the probability of school being closed is 0.5. So the numerator is 0.32, denominator is 0.5. That's going to give me 0.64 or 64%. All right, folks, that is it. That is all for this video. You know the drill. If at any point something does not make sense, please let me know. And as always, good luck, have fun, be safe, roll tide.